So here's a program that extends some of the work done in the unit vector and position vector programs. Notice here it has not only the XY coordinates but also an angle and an arc length entry. So here and here actually what I've drawn is the x-axis. When I click here, what happens is I get a vector. So this is a unit vector in the direction of the crosshair, but I also and so I'm recording the x and y coordinates of the head of the vector. I'm also recording the angle that's made with the x-axis here, and I'm recording the length of this arc. Okay, so all three of these values are related to each other, right? If we, depending on where we click, we'll get a certain xy, and that xy is going to match with exactly one arc length. If we restrict this to, being a radius of 1, right? Then there's exactly one arc length from here. So this is basically the point 1, 0. So there's exactly one arc length. If we're drawing a circle around this center with this radius, there's exactly one arc length from here to this point, to this xy point. And there's exactly one angle made between the x-axis and this point. And I should clarify that. What I mean by that is that there's one angle that goes, starting from here and going in a clockwise direction, right? Because you could go in two directions to get the other angle. But so there's this kind of there's a one-to-one relationship between these values. So there should be some kind of function, some kind of way, right, to get from one of these values to the other two. And in fact, there are. And exploring those relationships, there's a lot of great, powerful mathematics that comes out of understanding these relationships, and some cool applications in computer graphics. For example, understanding rotation in space, or being able to tell if a point's inside a polygon. You actually need to use some of the relationships that we see here. So I'm going to start with a discussion of those relationships, and then we'll at some point later on we'll have a chance to build this guy.